Alright, today, inequalities in two triangles, section 5.6. If you recall yesterday, we talked about inequalities in one triangle. Now today, we're going to talk about inequalities in two triangles. So section 5.6 today, inequalities in two triangles. Okay, the first thing we're going to talk about is what is the Hinge Theorem. Now it's called the Hinge Theorem because you think of like a door hinge, kind of makes sense that way. But the Hinge Theorem states that if two sides of one triangle are congruent to two sides of another triangle, so we have an example here, and the included angles are not congruent, included means the interior angles, then the included angle that is larger has the longer third side across from it. Okay, so Hinge Theorem again, larger angle, larger side. So if you look at it up here, just based on looks, obviously you would say LM is greater than HJ. Now again, we have a diagram down here at the bottom. Now it tells me the lengths are 3 and they share a side. So they have two congruent sides. Now the angles are 38 and 47. Which one is going to be longer, PQ or RS, Ryan? PQ is greater than RS. That's what we're going to be focusing on today. It's the inequalities in two triangles. Okay, next part here. So let's look at this here. Number 1. I have two triangles. If you look at them, I have congruent segments, so 11, 11, 10, 10. I have two congruent segments. And then I have two angles. I have 81 and I have 88. I want to compare TV to XY. If you were to compare TV to XY using an inequality symbol, what would your statement be, Camden? TV, sir. And why do you know that, sir? Very good, because angle S is less than angle W. I know then TV is less than XY. Nice job. That's the Hinge Theorem right there. Okay, so that big wordy theorem, that's all it's stating. Hey, smaller angle, smaller side. Bigger angle, bigger side. Number 2. Same thing now in reverse. Okay, I have a triangle here. Notice I have 5 and 5. 7 and 7. And I want to find, what do I know about angle G and angle L? So I'm looking at the opposite sides. I have 5 and I have 4. What can you tell me about angles G and angle L then? What do you think, Max? Very good. Angle G is greater than angle L. That's exactly what that Hinge Theorem states. Bigger angle, bigger side. Smaller angle, smaller side. Number 3. Now, notice here, trick question. Is this a straight line right there? Is that a straight line? No. Why? Nice job. Why is that not a straight line? Nick?
Because that's 100 degrees.
That's 100 degrees. So add it up, that'd be 190. Not a straight line. Good note. But I want to compare AB to AD. What do you know about those two angles then, Mr. Goldap?
AB is greater than AD.
I concur, sir. Good work. And the very last one, measure of angle FHE and measure of angle HFG. So I'm looking at those two angles. What could you tell me about those two angles, Drew?
Angle FHG is less than HFG.
I agree with that, sir. Nice job. All right, take a couple seconds. Try these 3 out. Very similar type problems. All right, let's look at number 5 here. I'm looking at angle K and angle M. So I'm looking at angle K and angle M. What do you say about those, Bryce?
Angle M is greater than angle K.
So could I say angle K is less than angle M? I agree. Nice job. I'm just going to repeat it in that order, but that is correct, sir. Good work. What about number 6, AB and DE? What do I know about AB and DE, Mr. Frost? I concur, sir. AB is less than DE. And the last one, I'm talking about QR and ST. What could you tell me about QR and ST, Mr. Wall?
QR is greater than ST.
I agree with that as well, sir. Nice job. That is it. Hinge theorem, not too bad. All right, now we're going to get a little bit harder. Not really. Okay, same idea with the Hinge theorem. As I look at these triangles, I have two triangles here. Okay. I want to find the values of x that could make the triangles true. So I'm looking at the two triangles. Notice the two sides are the same, but my angles are different. So for example here, this one has an angle of 66. This one has an angle of 71. What do I know about the opposite sides then? What do I know about MP and QR? What do I know about those? What can you tell me about those, Ryan? Okay, so when we work this out and solve for x, that's exactly what we state. MP is less than QR. So instead of setting them equal to each other, now I set them up as an inequality. And I solve getting x is less than 10. That's half of your answer right there. Because the second half comes from right here. In order to be a side length, it has to be bigger than what length? Anybody? 0. In order to be a side length, it has to be bigger than 0. So the second half of my answer is now I set it greater than 0. So I set it less than the other side, set it greater than 0, and I solve getting x is less than 2, or sorry, x is greater than 2. And now I set up my compound inequality. 2 is less than x, which is less than 10. All right, next problem here. Let's look at this. So number 8. I have my sides are congruent. Okay, I'm given that my sides are congruent here. Good. And I know that this angle is 46 and this angle is 51. So what do I know about 2x plus 4, Johnny? Nice job, sir. So 2x plus 4 is less than 18. And I solve the inequality. When I solve that inequality, what do I do to solve it, Keegan? How would you solve that? And then getting x is less than? $18 minus 4 is 14. 14 divided by 2 is? So we get x is less than 7. That's half our answer. Because how do I set up the second inequality then, Mr. Goldup?
2x plus 4 is less than?
No. In order to be a side length, it has to be bigger than what?
Greater than 18.
No.
0.
Has to be bigger than 0. Because in order to be a side length, it has to exist. So it has to be bigger than 0. So I do the same thing. Now I set it greater than 0. And I solve. When I solve that, I get what, Peyton? X is greater than -2. That's all right. That's good. And now I can set that up as a compound inequality, which would be -2 is less than x, which is less than 7. So what that says here is x has to be between -2 and 7. All right, number 9 here. Now we're looking at the angles. Okay, so I look at my sides. I'm looking at 23 and 26. What do I know about 3x minus 9 and 54? What can you tell me here, Jack? So 3x minus 9 is less than 54. And I solve. So what would I do to solve that then, Jack? Add 9. Getting 3x is less than 63. Divide by 3 and I get what, Jack? Good work. That's half my answer because I need to set up my second half. How would I set up the second half, Tyler? In order to exist, what's the angle have to be bigger than? No, Johnny?
3x minus 9 is less than or greater than 0.
Nice job, sir. In order to exist, it has to be bigger than 0. So I said the second half greater than 0. And you work that out. What do you get, Johnny?
Get to add 9.
Good.
So it'll just be like 3.
So x is greater than 3.
Yeah.
Now I put that as a compound inequality, which is 3 is less than x, which is less than 21. Plugging that in and solve. Good work. What about number 10? How could I set up number 10, Kay? What do you say? What's the first part of setting up number 10?
2x minus 7.
6, that's right. Nice job. And you would solve the inequality there. So to solve the inequality, you would add 6, divide by 2, getting me x is less than, what's 114 divided by 2? Mr. Null?
57.
57. So I get x is less than 57. And then the second half of my inequality. In order to exist, I'm going to set that second inequality. What would that be, Jersey? What? Okay. Greater than 0. It has to be greater than 0. So 2x minus 6 is greater than 0. When I solve that, what do I get, Camden? X is greater than 3? Good. And now I plug that in, getting me 3 is less than x, which is less than 57. Nice job, sir. And the very last one. Hannah, how can I set up the first inequality? How would you set up that first inequality? Because I'm given the angles are 53 and 58. Okay. So we're going to know about 5x plus 3. Yes, ma'am? Less than what? What's the other side like? Very good. 5x plus 3 is less than 38. Nice job.
How do you know what to pick? Like,
What do you mean what to pick?
how do you know what to like set it to? Like,
Because I'm looking at these angles, so I'm looking at the opposite sides.
oh, okay. I mean, yeah.
I'm looking at the opposite ones. Okay. So 5x plus 3 is less than 38. Nice. And I solve for x. What do you get x to be less than, Ryan?
I did that wrong.
Ah.
7.
So x is less than 7. Nice job, sir. Oops, I put 3. And then I set up my second inequality. What would my second inequality be? Caitlin? 5x plus 3 is greater than 0. When you work that out, what do you get, Caitlin? Yeah. I like fractions.
So we could have put the fractions.
X is greater than negative 3/5. I like fractions. X is greater than negative 3/5. Fraction. So then I have my answer here. What is my final answer here then, Tina?
Which one?
Number 11?
Oh, x is less than 5 and x is greater than 3
How about negative 3/5 is less than x, which is less than 7? I don't know what you're saying. I like that answer. Yes.
Wait, do you always take your second answer first then? Or is
The one
that-
he said, yeah, the one he put it's equal to 0 usually comes first. Okay, take a couple seconds to try these 4. Number 12. What do you get for an answer to number 12? Johnny, what'd you get, man?
I like 24.6.
No?
Like 74 divided by 3.
74 divided by
124.
174 divided by 3. I think you missed the 1.
174.
Which actually gets me then what, Bryce?
58.
So, give me the answer.
7 is less than x, which is less than 58.
Very good. 7 is less than x, which is less than 58. 7 is less than x, which is less than 58. Again, that first part comes from, or the second half, I guess, 3x minus 21 is less than 153. And I have 3x minus 21 is greater than 0. Okay? What do you get for number 13? What do you get for number 13, Tina?
I have 3/5 is less than x, which is less than not equal to 5. Should that be right?
Almost. Instead of 3/5, though, it should be 5/3.
5/5. That's what I got. I just said it wrong.
Oh, okay. 5/3 is less than x was less than 8.5 or 8.5. That's correct. Now, when you give both of them, that's okay. Do the same thing. We know that 11 is smaller than 12, so I would say 3x minus 5 is less than x plus 12. And you solve for x the same exact way. I would subtract x, add 5 to the other side, divide by 2, 8.5. And then somebody like, well, which one do you set greater than 0? Always take the smaller one. Okay, always take the smaller one. The smaller one has to be greater than 0. If the smaller one's bigger than 0, the second one obviously is bigger than 0, which makes sense. Okay. Number 14. What do you get for an answer to number 14? What do you say, Max?
-2 is less than x, which is less than 10.5.
Nice job, sir. I agree. Again, look at the angles. 111 is smaller than 118. So 3x plus 6 is less than 37.5. And the second half would be 3x plus 6 is greater than 0. And you need to work both those out. Nice job. And the very last one, number 15. Troy, what'd you have, man?
-4 is less than x, which is less than 1.
I think on this one they actually made a mistake on one of them. There should be a negative or a positive when there's not. Because you work it out, actually you get positive for it, don't you?
Yeah.
So I think when you work it out, you actually get positive for it. I think you get something like actually, what do you get? You get x is greater than 1 and x is greater than 4, isn't it?
Yeah.
Okay. So technically that one really has to be greater than 1 then, essentially on that one. But I think they made a mistake because I feel like this should have been like a positive 7 there or something like that. But anyways. Oh. Here is your assignment. What?